All right, so let's go through them. These are the answers that I've got. As you get more hours of sleep, coffee consumption likely goes down. So if you have less sleep, you probably drink more coffee. Temperature and ice cream sales, as it gets hotter outside, I'm sure you want, you know, a colder freezing snack more, so ice cream sales go up. If you spend more time shopping, chances are you're going to spend more money. No correlation, your distance to work and your salary. I'm sure, you know, you can think of people in your same job who live all across the city. It doesn't matter how far you live from your job as to what your salary actually is. And last one, ice cream sales and murder rates, which is kind of a surprising one or a harder one. They are also positively correlated, which you might feel like, what? Like, why people who buy ice cream more than murder more? Like, that doesn't seem real. And that's why I bring you to my second caution. Correlation, two variables being associated with each other, does not imply causation. This, if you take one thing away from this lecture, correlation is not causation. Ice cream sales do not cause an increase in murder. The two variables are associated. It's not true that one necessarily causes the other. So there are a couple reasons why that could be the case. So for instance, if you have X and Y being associated, maybe X causes Y, leads to Y, but maybe the reverse, maybe Y leads to X. Or you might have what we call a third variable problem. You have some extraneous, some different letter Z, variable Z, that actually independently affects them both. So to kind of put a concrete example to this, excuse me, in our first example, hours of sleep and coffee consumption, it could be that the hours of sleep you get causes or directly affects how much coffee you consume. So if you get not many hours of sleep, you consume more coffee. It could be the opposite though. It could be that the more coffee you consume, the less hours of sleep you get. So it could be the reversed causality, coffee consumption causing hours of sleep. Or there could be a third thing that's leading to both of them. Maybe take a second and pause and think about what other factors might be at play. So ones that I came up with perhaps, maybe how much workload you've got. So if you have a lot of work to do, maybe that leads to more coffee consumption and less sleep. Or how stressed you are, likewise. Things like that, some external factor might actually be driving or causing both of those things. So the two variables themselves aren't actually directly causing each other. So correlation is not causation. Another fun reason that I can tell you why that's not true is for what we call spurious correlations. And these are things that just happen to be related for no reason that anybody can actually think of. There's a beautiful website that lists a bunch of these spurious correlations. You can see this in the bottom right corner. But here are a couple that I find particularly interesting. So did you know that the number of people who drowned by falling into a pool correlates with the number of films that Nicolas Cage appeared in? Try to think about what might be causing how that works. What third variable? I don't know what it is. These are just randomly happen to match. We also have the per capita cheese consumption. The more cheese you consume correlates with the number of people who died by becoming tangled in their bed sheets. This is pretty tightly correlated. No one knows why. They're just random. Correlation is not causation. And last example I'm going to show you. Turns out that the number of letters in the winning word of the Scripps National Spelling Bee correlates with the number of people killed by venomous spiders. Yeah, so random correlation is not causation necessarily. Two things can be associated without causing each other. So let's think about it. We know that correlations are really good when you're trying to predict how one variable influences another, or perhaps when you're studying a relationship that might not be ethical to necessarily impose or experiment on more in depth. We're going to get into ethics a little bit later, but you can measure correlations pretty harmlessly in most samples. So cons of this, as we talked about hopefully multiple times, you can't infer causality with correlations. Correlations are not causality. And there's also the third variable problem. So you might be talking about these two cool things that are totally related, but in actuality, there's a third thing that's causing that might be actually, you know, more influential. So think about, again, maybe kind of pause here. How might we use a correlational study to test our hypothesis that an apple a day keeps the doctor away? Think about what your two variables are, and think about perhaps whether this correlation might be positive, negative, or zero.